Max and myself, we have like a similar history. So we both come from the Fraunhofer IGD, have been working there in a department and handling a certain scientific problem. So what I have done in my time at Fraunhofer, we have been working on augmented reality tracking systems for any kind of augmented reality purpose. So we developed lots of different tracking systems and created this as an SDK, just to provide this for anybody to use. So we started like our startup like 6 years ago. We named this visometry. Like the name, or like the idea of the name is to do something with vision, computer vision, which is like based on geometry. And so we have like two products. Like the first one, which we started, was like mostly the results of our Fraunhofer research, which is like an augmented reality tracking system based on 3D CAD data. And on top of this technology, we created like an end-user product for quality engineers, which can be used to identify differences between virtual and physical objects. So yeah, and so that like the VisionLab SDK, this is like a tool more like addressing developers who want to create like their own applications. And the problem was that like many customers said, yeah, this is great technology, but like how can I use it? So we created like this end user application, which we named Twyn, like in relation to digital twin. And like with the VisionLab SDK, many customers, like you see here on the bottom, created like different kinds of applications with like a very wide range of application areas like marketing, or also sales and training applications, or also maintenance instructions or quality inspections, also gaming. So it's like a very wide range. And so here this was like for example, like a marketing application where people could like visualize the interior of a powertrain to better let people better understand how this machine works with like all the interior animations. And so here, shortly just giving you a review about like the computer vision core system. So during the Fraunhofer time, we investigated in lots of different kinds of tracking methods. Like here this is an example of like a kind of structure for motion-based reconstruction of a point cloud, and using this to identify the camera pose in relation to some certain object. But like we also focused on model-based tracking and participated there in lots of tracking contests. So at that time there was also always these challenges: how can we localize the device or like the camera on any kind of input? And so like there were of course also markers or reference images, but of course for industrial purposes there was always like a big demand for using like 3D models, which are based like on CAD data as a tracking reference. And so because this is like the most interesting topic for like industrial use cases, we created like our first product, like the VisionLab SDK, where we mostly concentrate on this model-based tracking. And so, of course, there are lots of other augmented reality SDKs. Like here on the left side, we see like the IKEA Place app, which uses Apple's AR kit, which is like great technology for these visual inertial SLAM technologies, where you can just localize your device like anywhere in the room based on some reconstructed feature map. But like what's missing here is that you can place the context, the 3D content like precisely in any certain context. And so for industrial applications, typically there are always like parts or physical objects which you want to augment with graphics or 3D data. And so you need to be very precisely on this object. And so this makes the difference, which like the USP of our tracking system, that we are able to take the 3D data, use this as a reference, and then very precisely like being able to precisely place like 3D content or like 3D graphics. And so this is like the idea of our core engine, the VisionLib SDK. So mainly the input is like a 3D polygonal mesh model, which can be like any polygonal mesh format, and like a camera image of like some real object. And what our software does is detecting this object and precisely refining the camera position in such a way that the virtual camera and the physical camera are almost in place. And so we can use this technology on lots of different devices. So it's a cross-platform application which can be used like on the mobile devices like iOS and Android. We also supported like glasses like the HoloLens or the Magic Leap or other glasses. But these days the tablets like are kind of the more useful solutions, and we always try to advise our customers better think of tablets, because glasses are of course nice and innovative, and there are always lots of new glasses coming out from different companies, but from a user perspective, we have also put lots of effort into like these classes and made like user tests, and like this never worked out that well. And tablets, people were always happy with using tablets because they're easy to interact, and so we mostly focus on like tablets devices. Yeah, so this is like our core technology, and as I mentioned, we provide this for augmented reality developers who want to create like their own AR applications, or also augmented reality platform providers who have like their own AR platform or content system, and they use our technology underneath their augmented reality system. So yeah, so this was like our first product, which we have now on the market for 6 years. But like people have always been wondering, like, so how can I use this, and how can I quickly check like my 3D models on physical objects, so to to quickly detect like differences between like virtual and physical models. So this was one of the use cases we identified as very interesting and like very valuable for industrial applications, because of course marketing and training use cases are also interesting, but like we saw like the biggest value was in the area of quality inspection, because many production companies have a big pain in production quality, especially in like welding, for example, welding structures where things are produced in like very small quantities and like very high variations. And we try to address this problem with our solution Twyn. And so this is like a software solution where we address quality engineers who can use like a tablet PC. Here, like mostly we use iPads to identify like differences between their 3D CAD data and like the produced parts, with the idea to quickly identify errors very, very early in the assembly process. So here, this is like an example. There's some welding structure, and like the quality engineer can take his tablet, overlay the 3D CAD data, and check like if all holes and bolts are correctly placed, and then it identify if like here's some part is like a bit misplaced, so that there might be problems in the manufacturing or like the assembly process later on of the OEM. So, like an interesting fact is that it is a very like a sweet spot, like to use such a mobile augmented reality system for very, very large structures, because typically when people want to do some measurements, when they have like, of course there are like professional measurement equipments which can also do precise measurements, but then this inspection takes like quite a long time, and you need to set up the whole thing and calibrate like the correct coordinate systems. But when we take the 3D model as a reference, like a big benefit is that you don't need to do any setup and prepare lots of stuff, like putting your 3D data in the correct coordinate system, do some calibration. But you can just directly use it right away and like anywhere. Like for example here, for these very big parts, like it's very easy to just go somewhere on the shop floor and do like an overlay of these very large structures and to quickly identify like differences. So here we have like one of our customers, they use our software in the area of inspection of incoming goods. So yeah, as I mentioned already, when before parts are then put into the assembly, they check them if like every parts, all the holes are correctly drilled and that there's no misplacement of manual welded parts in these structures. And so, of course, this is interesting as like for very small quantities. When they're like, if there's any mass production, then there are like also inspection systems where it's okay to put like 2 weeks effort into like preparation and training and learning of the whole system. But sometimes for these customers, they have like sometimes very, very small quantities and do lots of preparation, and pre-processing is just not beneficial. And so if you directly work on the CAD data without any preparation, then it's like a very easy way where you can do like a direct comparison between virtual and physical models. And so here the whole solution consists of like 2 parts. We have like this the Twyn Studio, which is like a desktop software, which is used to set up the scene, where you can just import your CAD data and transform your CAD data and create like the step-by-step instructions for the quality inspection process. And then all this is packed into like into a project file, which can be transferred to the iPad. And on the iPad, like we call this Twyn View, the app, which is then used to carry out the inspection process, where you can just go through your steps and switch different visualizations to check like differences between like virtual and physical parts. And the result of the whole, or like the result of the process is like a documentation. So we get like a PDF report where like all the differences are documented, and like screenshots can be captured of like annotated like screenshots where things are not matching. And so it's like very easy to create like such a documentation within minutes by just like comparing virtual and physical parts. And yes, now the problem, like here this is just like a very small and kind of simple part which works quite well. But like our customers, they also started to put like very large CAD files into our system. And so this also kind of worked on the Twyn Studio side, when you just take like a couple of gigabyte model, when you have like a powerful PC with lots of memory. But like on the mobile apps, because like our computer vision algorithms, they directly operate on the polygonal mesh model. And so if these polygonal mesh model is just like too huge, like it of course has like a big impact on the performance, on the frame rate of the tracking system. And like if the tracking frame rate is just like too small, then the overall augmented reality experience gets very bad when you have like just like not a 30 frame tracking, but just more getting like a slideshow where you have like only like a couple of frames, which like completely destroys like the user experience. And so, yeah, like we had this need of taking these really large 3D CAD files and put them in a more compact form. And so this is why we integrated the Rapid Compact in our Twyn Studio. And so now this makes it possible that we can just import like very large 3D CAD files into our system and make like a very compact representation for the tracking. And so for tracking, it's also mostly only necessary that you only see like the 3D data which is really visible. So like every hidden geometry is like not needed in many cases. So this also helps to really reduce like the geometry to like a very compact format. And then this, of course, makes it possible also to, if you have like really large original 3D CAD data, to put them into a representation which can be easily deployed on an iPad with like way less of the original data size. And so it's like a very easy process, so the user doesn't really feel anything, that there's like lots of reduction happening inside our system, and this many stuff happens like under the hood, but like there's still some advanced features that you can still select a couple of parts which shall be reduced more or like which shall be reduced less. So depending if there are lots of holes where you really need like round structures, if the compression is too high, then of course the quality gets like a bit worse. But it's nice that you have like the online possibility in the application to modify also the compression rate in such a way that you always get like visual appealing results for the final deployment. And like what's also a very nice feature is that we still can preserve like the whole 3D structure. So if there's like a complex CAD model with different components, in our application we also have the opportunity, the possibility to select and remove certain parts and take certain parts also as test geometry. And of course that's very like necessary for this use case, to preserve like the geometry, not only having like one big soup of polygons which can be rendered fast, but like having the structure of the 3D model which can then be also modified or adapted in the application. And then, yeah, we get like a compact project which can be used then on the application. Here's like another use case of a customer. So these are like fixtures, and so here like our application is used to identify these parts and to check if they are all set and assembled in such a way that they can be used like for producing other stuff in a useful way. So yeah, here there's like also some features like this lens features with like a clipping line where you can quickly switch between virtual and physical, and also change like transparency, that you have like good tools to identify like these differences. Then, of course, what's like in the first place, the whole thing was intended like for people to use this as a visual inspection tool, to compare like the differences just by looking at them, and to make a decision by like seeing the differences between certain parts. But what we also do with our computer vision system is also to check like different geometries in relation to each other, with the idea that like a quality engineer can also be assisted to quickly detect changes or like things. For example, here there's like this window lifter in the car door which is like misplaced, and because we can check the car door and also the window lifter as two different geometries, we can also detect like that if the window lifter is like in the correct tolerance range in relation to the car door, and this shall be like the way to like a more automated a quality inspection, so that we use the computer vision system not only for detecting the orientation and position of objects, but also use the computer vision for automatically detecting the correct placement and alignment of certain parts. Yeah, so that's our solution. Then I think I'm through with presenting our Twyn solution and the VisionLab SDK. Then, yeah, thank you very much.